this problem, we have a mass that is supported by a set of springs with a combined stiffness of 6.4 pounds per inch. The system is lifted and then released, and we are asked to find the maximum displacement of the mass and the maximum compression, the time for maximum compression. So let's first find the original or the deflection at static equilibrium. So for that, we can simply know that at static equilibrium position, we have the equation, if we assume forces in y is going to be equal 0, and from here, we can find that the spring force, which is opposed to movement, plus the weight are going to be the two forces acting on the system. And then from here, so we know this is equal to 0, so we'll know that the spring force equals the weight. Now the spring force is the stiffness and the static deflection multiplied by the static deflection, which equals mg. So now from here, we find that the static deflection is mg over k, and this is our equation for the static deflection. Now, we know that the maximum displacement is going to be 2 times that deflection. So let's calculate what is the static deflection. So we're given the weight. So the static deflection is equal to the weight over k, which is going to be equal to 38.6 over 6.40. And that is going to be equal to 6.4 inches. Okay, now we have the static deflection and the maximum displacement is equal to 2 times 6.04 inches, and then it's going to be equal to 12.08 inches. Now let's find the time. To find the time, we need to first find what is the natural frequency of this system. So let's find the natural frequency of the system, and we know that the equation for natural frequency is k over m for this system. And we also know that since we're given weight, let's put this, rearrange this equation a little bit further. So I just do kg over mg. This is the weight. So I'm going to use this equation. So we're going to substitute values here, 3.4 for the gravitational acceleration, which is equal to 386.08 over the weight. Okay, and that is going to give us a value of 8 radians per second. Now we know that the natural frequency is 8 radians per second. We also know that the natural frequency is related to the period by the following equation. Natural frequency is equal to 2 pi over period. Now, let's find what is the period. The period is given by 2 pi over natural frequency, which is going to be 2 pi over a, which is 0.784 seconds. Now the time for maximum compression is going to be half the period. So it's going to be 0.392 seconds. And that's the time that we were asked to find in the problem.